Hello guys, welcome to a new video. Today we're gonna go over chapter 4, axial or equatorial in cyclohexanes. So the first thing we have to do is be like, what's a cyclohexane, right? Before even like looking at what's axial or equatorial. So cyclohexanes, right? So from my video from UPAC, you should know what an hexane is. Hexane is telling us this an alkane. Right? So an hexane will be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Yeah, 1, 2, 3, 4, 5, 6. So that's an hexane. It's A and E. So there is no double bonds, only single bonds, right? But now there is this little word over here that says cyclo. So what the cyclo is telling us over here? It is cyclic. So it's a ring-like structure per se. So it's gonna be 1, so 1, 2, 3, right? And after that we connect it to 1, it's like that. So it's gonna be 1, 2, 3, 4, 5, 6. Or you can do it 1, 2, 3, 4, 5, 6. But just like two little triangles connected, if you think about it. That's a cyclohexane. So, cyclo in front of something makes it ring-like. 34. So you see it, you see a bunch of words, you see a big drawing, you're barely introduced to the topic, and you're like, what's all this? Don't get overwhelmed. It's really easy. I picked it up because I thought it was going to be hard, so I wanted to explain it up. And after picking it up, I was like, this is easy. Like, this better than this explication. So just the first thing when reading a problem, when looking at image, before you do anything, you ask yourself, what's the question? What needs to be answered, right? So the problem goes like this. It says hydrocortisone, a natural occurring hormone produced in the adrenal glands, is often used to treat inflammation, severe allergies, and numerous other conditions. Is the indicator OH group axial or equatorial? Okay, so OH group. This is an alcohol. Whenever you see an OH group, it's an alcohol. OH is a functional group, right? So it's gonna be branching off. It's gonna be an alcohol, right? So it's asking us if it's axial or equatorial. Basically, axial groups are gonna be up or down before the chair flip, right? And equatorial, they can be up and down too, but they're like more like up and down, you know? Equatorial. So equatorial like groups that like kind of branch off like sideways. Alright? So you get to the image, right, and you see these are different cyclohexanes conformations we can have. So we have 1, 2, 3, 4, 5, 6, that's like the chair conformation. You have double bond over here, but this is not the main point of the question. The main point of the question is this OH group axial or equatorial? So the molecule or the bond is pointing up, which is axial, it's pointing vertical, right? If it was pointing like this, it could be equatorial, right? But it's pointing up. So this OH group over here would be a good example of something that's equatorial because it's pointing like straight, right? So axial, up and down, equatorial to like the sides. So this is gonna be your first time using the organic molecular model kit, right? So let's see, here's my model kit, right? It's cutesy. And right here I have a carbon. We know it's a carbon because it has 4 connections that represents the four bonds that carbon can make, right? So I'm using the chair conformation this time, right? So to do the chair conformation, you're gonna put one carbon up, one carbon down, one carbon up, one carbon down, one carbon up, and one down, right? So I'm gonna do hydrogen bonds so you can visualize this. Okay, so if the carbons are connected to each other in a ring-like structure, right? Like it will be like cyclohexane, right? And it's a chair conformation. So that means the carbons are connected to each other. So that means there's two bonds to fill, right? Like there's two electrons to be shared, right? So that means we're gonna have 6 axial and 6 equatorial, right? So y'all wanna help me a little bit. This is sticking up, right? We say it was axial, right? This is sticking up, is axial, but this one is sticking out. So what do you imagine this one will be? This one will be equatorial, right? But it doesn't mean that it's sticking up, or like it doesn't have to be sticking up to be axial, right? What if it's sticking down? What if it's one like, I'm sorry, it's kind of hard. Okay, this one is sticking down and it is axial as well, right? This one is sticking down, but it's axial as well. And this one is sticking down, but it's axial as well, right? So what are the rest of them? Even though this one is kind of shooting down, and this one it's kind of, okay, this one's shooting down, but this one is kind of like shooting up. They still equatorial. Why? Because it's not, they are horizontal for most of the part, you know? So that's why it's equatorial. So all of them are going to be green. I hope this helps understand axial and equatorial bonds, right? So this is how my molecule looks, right? So we stick 3 carbons on top to make the chair structure, and we stick 3 carbons on the bottom, right? So we have the axial bonds and the equatorial bonds, right? Bro, now we have the axial on the top and the equatorials on the side, right? But something cool, what happens, like whenever you do the chair flip, it doesn't mean you flip it like this. No, it means the carbons are literally flipping. Like the carbon that used to be down is gonna go up, right? So the carbon that you had down, you're gonna put it up. The carbon you had down, you're gonna put it. Okay, bro. Okay, yeah, you're gonna put it up. The carbon that you used to have down, you're gonna put it up, right? So you should have all the carbons that were down now are up, the carbons. So what happened to them? The bonds that used to be equatorial, the molecules that used to be equatorial, now are axial, right? So these hydrogens are now axial. So in the chair flip, equatorial and axial switch places. You see, now the green ones are axial and they used to be equatorial, right? And all the white ones are now equatorial. Okay, so I'm going to the axial. The molecules are axial, the bonds are axial. I'm gonna put them a different color than the equatorial ones. I'm gonna be using green and white, right? The green ones are these ones, and they're pretty big compared to the ones that are hydrogens, like. But this is just for representation. Let's imagine that they're both the same size. In real life, hydrogens will be smaller because the molar mass is smaller. This one could represent another like molecule that has a bigger molar mass, right? In real life. So if you have any questions, let me know in the comments. If you want me to make a video on a specific subject, please let me know. I hope this video helped you illustrate between axial and equatorial in cyclohexanes. And Have a great day.